Okay, yesterday we looked at expanding expressions so that we could get expanded version. Today what we're going to do is look at what is the opposite, and the opposite is called factoring. Before we get started on factoring, we got to review some basic skills from elementary school about greatest common factor. Okay, so our example is going to be find the greatest common factor of 18 and 24. Okay, and to get started, let's choose a pen. Right, here we go. So we're going to find the greatest common factor of 18 and 24. Now the greatest common factor is the biggest number that will divide both of those nicely. Okay, so the easiest way to do this is to think of numbers, but we want the biggest one. So what I like to do is list the factors of each number. So the factors of 18 are 18 and 1. They're 6 and 3. There's 2 and 9. And there's 4. If we check 4, 4 is not going to divide 18. 5 doesn't divide 18. And then we're already up to 6. Okay, so we checked 1, 2, and 3. Those all divided, and we get those results. Okay, so now what we're going to do is we're going to list the factors of 24. Okay, so it's 24 and 1. There's 2 and 12. There's 3 and 8. There's 4 and 6. And 5 doesn't divide 24. 6, we've already repeated ourselves. Okay, so what we're going to do now is looking at the common factors. 1 is a common factor in every number. We've got 3 is a common factor in both. Okay, so 3 here and 3 there. 2 here and 2 here. And 6 here and 6 here. Now, the biggest one is what is the greatest common factor. So the greatest common factor of 18 and 24 is equal to 6. Okay, so it's basically, as you remember it, is the biggest number that will divide both of those numbers perfectly. All right, we need that in order to factor expressions. Okay, so the algebra involved with factoring is really what we're doing is going in the opposite direction of expanding. Yesterday we took expressions that, here's a small example, we took expressions that look like 2 and then x plus 1, and we expanded that. We got the brackets out of there by multiplying. So 2 times x and then 2 times 1, which gave us 2x for 2 times x, and then plus 2 times 1, which is 2. Okay, so what we're going to be doing is the exact opposite of that. We're going to be taking the expanded form and putting it back into the factored form. Okay, so let me get rid of this, and then we will expand, or sorry, factor. So if we're going to factor this, what we're looking for, and there's some steps, we're trying to figure out what is the factored form of that. It had brackets in it to begin with. We're trying to figure what goes in the brackets and what's going to be outside. Here are the steps that we're going to be looking at for all common factoring problems. The first thing we're going to do is look for the greatest common factor of all the terms. In this expression, we have 2 terms, 1, 2. So what we're going to do is look for the greatest common factor between 2x and 4. The way I like to do it is look at the numbers first. What is the greatest common factor between 2 and 4? You're going to say the greatest common factor is 2, and then what we do is do the second step. Write the greatest common factor out in front of the brackets. After that, we do the third step, which is divide each term by the greatest common factor and write the result inside the brackets. So we're going to take 2x and we're going to divide it by 2. 2x divided by 2 is just x. Positive 4 divided by 2 is positive 2. And then once we divide by each of those terms, we could do a check to see if that works out. So the check is to expand the result back into the expanded form. So if we have 2 and we have x plus 2, if we expand just like we did yesterday, 2 times x is 2x and 2 times 2 is 4, and that checks out. Okay, so these 3 steps we're going to follow for all common factoring problems. Look for the greatest common factor of all the terms, write it out front, divide each term by the greatest common factor for the inside the brackets. Okay, so let's factor this. So for our steps, we have find the greatest common factor. Now, we've got 2 and 6 as numbers, but we also have x's in each term, so they're common factors of x in each of the terms, and there's 2 terms. So, looking at this, we've got 2 and 6 and x and x. So the greatest common factor of these 2 terms is going to be, the greatest common factor between the numbers is 2, and the greatest common factor between the x's is just 1 copy of x. So the greatest common factor is going to be 2x. So to factor this, we're going to do our second step, because we already did the first. We found the greatest common factor. Second step is to write down the greatest common factor out front, and then inside the brackets we divide each of the original terms by that greatest common factor. So as a side, we'd say it's 2x squared divided by 2x. That's going to give us x squared divided by x will leave us with just an x, and 2 divided by 2 is just 1. So it's a 1x, but I'm not going to write it. So that leaves with x in this spot, and then we'll do minus 6x divided by 2x. Minus 6 divided by 2 is going to be minus 3. And x divided by x is just 1. So this is going to be minus 3. And again, you can do your check to expand that. 2x times x is 2x squared, and then 2x times minus 3 is minus 6x. Okay, so that's going to check out.